Hi everyone. As I mentioned at the start of this combinatorics unit, combinatorics is very closely related to probability because the probability of an event happening, event A, is given by the number of possible ways that will give a successful outcome for event A divided by the total number of possible arrangements, if you like, in the sample space. So, in order to answer a probability question using our knowledge of arrangements and counting methods, we just need to be able to correctly figure out the number of events or a number of outcomes in the event space and the number of outcomes in the sample space, and then use this formula to be able to figure out the answer. Often this will be involve choosing whether or not we're going to use a permutation. That is when order is important. Or when we need to use a combination. When the combination is just when the objects are important, but the order is not important. So order, not important. Okay, so let's do just two examples to try and help you out with this. Okay, this person, Jill, she guesses what the top 3 teams are going to be in a basketball league of 8 teams, and which will finish first, second, and third. What is the probability that she gets the top 3 right? Well, first we need to figure out the number in the event space. Okay, now the event A is Jill getting her guess right. Now she guesses who's going to be first, second, and third, so there's only one guess that's made. Okay, so the number of successful outcomes is 1. Now we need to figure out the number of events that are in this sample space. And that's basically the number of arrangements, the number of ways that we can have a first, second, and third team out of 8 teams. Okay, so we have 8 teams here. Oh, I shouldn't do this so close. We have 8 teams, and we want to arrange them into the 3 top positions. And in this case, we've got to figure out, is order important or is order not important? Is it important which came first, which came second, which came third, or does it not matter as long as they made top 3? And here it says that Jill actually did guess which one was first, second, and third. So order does matter, and so we're talking about permutations because order does matter. So what we're doing here is 8p3. So that is 8 factorial over 8 minus 3 factorial. So that is 8 factorial over 5 factorial, which is 8 times 7 times 6. Put that into our calculator and we'll get the correct answer. Okay, second example. Might need a little bit more room for this one, I think. Okay, so in this example, we have a committee of 5 people to be randomly selected from a group of 6 men and 4 women. What is the probability that the committee will contain 3 men and 2 women? So we want the probability 3 men, 2 women. Okay, so we need to find the number of, so our event A is 3 men, 2 women. So we need to find the number of ways we can get 3 men and 2 women. Well, let's see. Well, the number we can get 3 men is if it doesn't matter which men, doesn't matter their order. So we're doing combinations here, and we need to choose 3 men. So our R is 3, and we have 6 men to choose from. So that's 6C3. And now we need to multiply all the different ways of getting 2 women. So another combination, we're choosing 2 out of a group of 4. So we go, so if we jot this down, 6 factorial over 3 factorial, 6 minus 3 factorial, times 4 factorial over 2 factorial, 4 minus 2 factorial, which gives us 6 factorial over 3 factorial, 6 minus 3 is another 3 factorial, and now because we're multiplying, that's a 4 factorial, 2 factorial, and another 2 factorial. So there we go. Put that in our calculator, and we will we'll get the number in our event space A, and I'll do that in a second. Now we need to know the number of total ways that we can select a committee. The total ways of selecting a committee. Well, we want a committee of 5 people, so that means R is 5. So we're doing combination R is 5 people in our committee. And our group size is, well, there's 6 men and 4 women. So overall we've got 10 objects. So it's 10C5, which is given by 10 factorial over 5 factorial, 10 minus 5 factorial, which is 10 factorial over 5 factorial times 5 factorial. Okay, so we're doing this number here divided by this one here. So assuming that you're all super good at your fractions division, which hopefully you are by now, we'll keep the top stuff here, 6 factorial, 4 factorial, and the bottom stuff goes up there too, 5 factorial, 5 factorial. And now on the bottom we have 10 factorial, a 3 factorial, another 3 factorial, 2 factorial, and another 2 factorial. Okay, there we go. Big bunch of factorials going on. So let me just put all of those into my CAS calculator, and I will find the answer. Well, look, let's just say that I found the answer, because to be honest, I can't be bothered. You can figure that answer out for yourself, but this is the stage where you say calculator. Okay. By the way, you possibly could have done calculator right from this step here, combining it with this step here. So if you wanted to find the answer just using a calculator, you could have easily just done 6C3 times 4C2 divided by 10C5, and that also would have just gotten you the answer even more quickly, even more easily. So there you go. Now that's basically all you really need to know. There's a few other things though, so a few other tips and hints is, if in doubt, do a tree diagram. Tree diagrams, they will be very helpful for you. Also remember some of the other things we've learned about things when they're in subgroups and things when they're in circles as well. Those possible things will come up, and so will conditional probability stuff. So you'll have to remember the formula of that looks like this for the conditional probability. So there you go. If you want to pause and jot that down real quick for conditional probability, you can, but otherwise go through some of the past videos. That's all the information you need, and that is the very last video for this whole maths methods section. I may create some more as like extension methods, but that is essentially the whole methods course, everything that's required. So well done for making it this far through, and all the best for your revision, and I hope to see you in Year 12 methods. Alright, see you later.